First of all, make sure that you're on the side that says set 1. Make sure you're on the side that says set 1, okay? All right, so here's your answers. Let me see if I can get this where you can see them. Okay, so here's your answers. Just a couple of things. Folks, remember that when you're multiplying to get a positive number, you got two choices. You're either going to be two negatives or two positives, because a negative times a negative gives you a positive, okay? When you're multiplying for a negative number, one of these numbers has to be negative, just one of them, because a positive times a negative is a negative. So, I found this one, I did these myself without a calculator. I found that one to be difficult. Why? Because it's a big number. But y'all, it ended in 4, so the first thing I did was start breaking it down by 2s. I divided by 2. And when I divided by 2, I got 42. Well, 42 has a factor of 7, so then I started thinking about factors of 7. So that's what the thought process, that's what I did in my head without that. Okay? That was a little tricky because I kept zoning in on 25 times 3, but then I realized that 5 would go into it, and so I put 5 into it in my head, did some long division in my head, and came up with that one, negative 15 and 5. Okay. Be careful with the 6s, y'all. The 6s, multiplying to get a 6 will mess you up big time. Okay, because you've got this and you've got this. Okay, sometimes people look at this and go, oh, you know, they don't realize that this doesn't multiply to be a positive, but they pick the 1 and the 6 because when they subtract that, they get 5. But y'all, it doesn't work that way for this. Now, if I had put a negative 6 here, then that would be the magic numbers. But since it's a positive 6 there, that's your magic numbers. The 6s can be tricky. Okay? Any question on this side? How many people got more than 5 right? Okay. All right. Good, good, good. Okay, let's look at the other side. All right, this should say set 5 at the top. Okay. And again, notice, if you're multiplying to get a negative, one of the numbers has to be negative. You're doing a subtraction is what you're doing here. Okay, if the top is positive, you can either have 2 positives or 2 negatives. And then the bottom, you're actually adding those. How many people got 5 or more of these right? Okay, all right. Benchmark Monday, March 31st. Test this coming up Friday. The test this Friday will be heavy on factoring and solving by factoring. We're going to start that tomorrow. Not hard. The factoring part's the hardest. And also, don't forget, you've been learning about systems and graphs in advisory. So there will be some of that on there as well. Okay? Solving a system. Okay. All right. Okay, so real quick, I want to do something in your notebook. So if you guys will flip your notebooks over to where all the 7 show, to where all of page 7 shows. This is not going to be brutal. This isn't going to last long at all. And if you have a highlighter, probably be good to get one, because I'm going to highlight the same things all the way down, okay? Okay, so the title is perfect squares, so let's get started. 1 times 1, what's that equal?
1.
So 1, the number 1 is a perfect square because it breaks down into two factors that are exactly the same. So 1 is a perfect square. Okay? 2 times 2. What's 2 times 2?
4.
4 is a perfect square. 3 times 3.
9.
Okay? Hopefully y'all see where we're going with this. These are your perfect squares. So let's just speed it up. 4 times 4. 5 times 5. Going to come over here. 6 times 6. 7 times 7. 8 times 8. 9 times 9. 10 times 10. And for math 1, I think they go a little bit further. They do 11 times 11. 12 times 12. Okay. All right, so put your numbers there. See if you can do that without me. Probably can. It's probably simple stuff. What do all of these equal? That's about right. There's 5. Yep. Okay, so I'm highlighting the perfect squares. 16, 25, 36, 49, 64, 100, 121, 144. Okay, there's more obviously, but for the most part, it'll be maybe up to the 12 times 12 without a calculator for you. Okay. So y'all, when you see these numbers, when you have those two terms with the minus sign, you know, kind of there should be a signal go off, and you're like, wait a minute, that could be a perfect square. I could be factoring this by a perfect square. Okay, now, let's talk about the variables that are perfect squares. Okay? Okay, y'all, the variables have to have an even power so that they can break out. Okay, so for instance, what is x times x? Maybe I should ask this first. What are you doing with powers in a situation like this? What are you doing with your powers? You're adding them. So x times x is x squared. X squared times x squared. X to the third times x to the third. X to the fourth times x to the fourth. I'm going to stop at x to the fifth times x to the fifth. We'll do some crazy ones. Okay. So what's x squared times x squared?
X to the 5th.
Okay. And see, all these are your perfect squares because you can break them out into x times x. Same factors. The same factors. Okay. How about x to the third times x to the third?
X6.
That's right, because we're adding x to the 6th, x to the 8th, x to the 10th. You know, any variable that has an even power is a perfect square, and it can be broken out into the factors that are the same. Okay? And even crazy ones like this, that would give you x to the, notice, x to the 5th y cubed is multiplied times itself. That would give you x to the 10th y to the 6th. So x to the 10th y to the 6th is a perfect square. even powers, okay? Okay, so for this, just a reminder. We're going to do more of this, but you'll at least have it right here in your notes. Factor by difference of squares. You guys have already done this. It's the easiest one. So, let's see. X to the 6 minus 49. Actually, yeah, we'll just do 49. Okay? X to the 6 minus 49. Well, y'all see 49, when I see 49, I go, wait a minute, that's a perfect square. And then there's a minus sign, there's two terms, and that's a perfect square, so I automatically know this is the easiest factoring method there is. The same things are going to go in the front slots, and the same things are going to go in the back slots. And there's one plus sign and one minus. So from last week, what's going to go in the front slots? X to the third is going to go in the front slots because y'all, this first term breaks down into x to the third and x to the third. What goes in the back slots?
7.
7 and 7. Y'all, that's called factoring by a difference of squares. It only works with two terms. Two terms, difference of squares. Okay? All right. I just wanted you to have a list of perfect squares. Okay. All right. Okay, next thing, and that's it. That's it for this. I wanted you to have it, wanted you to see it. That's all for your notebook for today. Okay, the next thing we're going to do, more factoring. It's not new methods, it's just more of this right here because we got to get good with it. So what we're going to do is we're going to do practice for about 20 minutes and then you're going to do a delta math. Okay? So I'll say again, if you feel like that you want these in your notebook, or I shouldn't say in your notebook because there's really not a spot for it, but if you know that you want a paper copy of this, then get out a piece of paper. If you're like, no, I've been doing pretty good at this, I'm just going to use a whiteboard marker because it's fun, then feel free, get whiteboards and markers. It's up to you. It's your choice. Individually, what you want. If you want whiteboards and markers, get them. If you want a piece of paper, do a piece of paper. And yeah, you know, there's back sides in your notebook. There's backside sheets, so you could actually put it in your notebook if you wanted to. So we pull out the greatest common factor, negative 2x squared. We set up a parenthesis. How do we determine what goes in the parenthesis? Well, we're going to divide by your greatest common factor. So you're going to divide by negative 2x squared in all three terms. Now, y'all, you need to realize, y'all, dividing by a negative is going to change these signs inside of here. That's the reason why you pulled the negative out. So be careful with your signs. So again, take a couple seconds and see if you can divide and fill in your parenthesis. Okay, so 4x was my greatest common factor. So pull that out and set up a parenthesis. And now we should have, when we divide, x squared plus 14x minus 15. See, all this is a trinomial, so what you're going to do is set up that 2 by 2 box. And don't forget, your final answer has to have the 4x in it. Your magic numbers were 15 and -1. Don't forget your X's. So magic numbers were 15 and -1. So when you do greatest common factor, you get an X. See, this is where the negative shows up twice. That's where the negative shows up twice. -1 there. Here you get an X, and here you get a 15. So we've got X minus 1 in one of the slots, X and 15 in the other, and then we see the signs are different, and that's kind of what I was talking to Tucker about. See, we know the signs are different, but if you pull the negative out when it shows up twice, then you don't have to think about which sign gets what. Okay? Okay, let's do this one. Pull out a GCF, set up a parenthesis. When you get done with that, it's going to be a difference of 2 squares. What did y'all get for your greatest common factor there?
2x.
Okay, so I'm going to leave myself a little bit of room. It's 2x. So I'm going to divide by my GCF. Okay. So what do we get when we divide?
9 is it 8?
9x to the 8th, because we subtract these powers. And this tricks some of y'all. What goes in that last slot? That's right, a 1, minus 1. Y'all, when everything cancels, it's a 1. Think about it. 2 divided by 2, I realize we cancel those, but y'all, 2 divided by 2 is 1. Okay, now look, 9's a perfect square. 1 is a perfect square. X to the 8th is a perfect square. 2 terms, a difference of squares. So now, not much work to be done. One sign is positive, one sign is negative, and don't forget, if you had a GCF, it's got to be a part of your answer. Now fill in your spots. And yes, I put the minus sign first this time just so y'all get used to it. It doesn't matter with dots, y'all. I call it dots, difference of 2 squares. It's called dots. I mean, you can have the first sign plus and the last sign minus. It doesn't matter. Okay, what goes in these first slots in each parenthesis?
3x to the 4th.
9 breaks down into 3 and 3, and x to the 8th breaks down into x to the 4th and x to the 4th. So 3x to the 4th goes in the first slots of each parenthesis. What goes in the last slots? 1 and 1. Factored form, standard form. Okay, last 2 before we do delta math. And I changed it up just a little bit over here. Okay, so last 2. You've got a delta math on this, on these as well, and I've separated the sections. Y'all, there's one section that's going to be GCF, then trinomial. There's another section that's going to be pull out your GCF, then it's a difference of squares. There is a third section, and I'm going to show you what it is. First of all, can I pull out a greatest common factor here?
No.
I cannot pull out a greatest common factor. However, it's got two terms. Is 81 a perfect square?
Yes.
Is 16 a perfect square?
Yes.
Is x to the fourth a perfect square? Yes. Is there a minus sign?
Yes.
It's got to be a minus sign. So, we're going to set up two parentheses and do the fun factoring. Okay, first thing I want you to do is fill in the front slots and fill in the last slots, and then I'm going to show you something crazy. Okay, what did you fill in for your front slots? 4x to the power of 2. Okay, what did you fill in the last slots? Okay, now, here's your aha moment. Y'all, that's another set of perfect squares.
Oh my goodness.
That is another set of perfect squares. Look, 9, 4, x squared, and a minus sign. This one can be factored again. Now, can this one be factored again?
No, because no minus.
There is no minus sign. This one cannot be factored again, but this one can. So y'all, this one, we're going to factor it again. So I want you to ignore that for now, and I want you to set up your two parentheses, plus and minus, and I want you to fill in the blanks. Okay, what'd you put in the front slots?
2x.
2x in the front slots. What'd you put in the back slots? 3. Okay, now y'all, if you're like, well, Miss Patrick, how do we know we stop? Y'all, when you get down to an x to the first power, y'all, that cannot be broken apart. X to the first power, there's no way to break that thing down again. There's no way. So that is a clear indicator you're done. Okay, don't forget, y'all, this was part of my factors. It's got to come down as part of my answer. It has to come down as part of my answer. So y'all, the fully factored form is right here. We went from this to that. Okay? Now I want y'all to try this one. You're going to factor by difference of squares twice. I want y'all to try this one. Just like we did this one, I want you to try that one. Okay, what'd you get in the front slots?
9x to the power of 6.
9x to the power of 6. What'd you get in the back slots? Factors of 1 or 1 times 1. Okay, now take a look. Plus sign, so definitely can't factor this again, but look at this. 2 terms, perfect squares with a minus sign. Y'all, that gets factored again. So now I want you to factor that again. Okay. You should have gotten 3x to the third in the front slots and 1's in the back slots. And again, how do I know that I can't factor this again? Y'all look, that's an x to the third power. You can't get that broken out evenly. Okay? And then don't forget, this original factor here is still a part of your answer. So there's actually 3 parentheses here. Okay? Okay, so Delta Math. These, factoring twice, is going to be in there. Pulling out a GCF and then doing difference of squares will be in there. Pulling out a GCF and then your trinomial will be in there. Okay? Okay. I am going to very quickly adjust your Delta Math. I probably have too many problems in there. Okay, it's ready to go. All right, folks, you are going to need scrap paper. You know, I'm sure some of y'all already got your whiteboards. I guess if you want to use them, you can. If you hit a snag, I need to see what's written. I need to see what you typed in, and I need to see what was written on your board or your paper, or I can't help you, okay?